Okay, so we're going to work on solving this equation, and you might notice there's something a little different about this question, right? This doesn't show up anywhere on our unit circle, at least not in this form, right? We're used to more exact forms. We're used to looking at things like 1/2, √3/2, right? Really nice and like clean looking output values. So this one's a little different. So we actually apply our inverse trig to solve something like this. So we start off with x is equal to tangent inverse of this 3.0144 value. And then to be able to get an approximation, I guess I should use an exact form for now. To be able to get a value for x, we actually need to use our calculator. So I'm going to open up my calculator. One thing I want to point out is make sure that you're in radians. The reason I know that we're in radians is because this is using 2 pi over here. If this was like 360 degrees, then I would use the other format, but definitely radians, so make sure you're in radians. The way that this calculator works is I type that value first, and then I go to trig, second, there's my tangent inverse, and it gives me an output right away. Now, this is obviously a very long answer, right? We're going to copy it. And then I'm going to come over here and I'm going to paste that. Now, again, super, super long answer. Do we need to keep all of that? I would argue no, we don't. So I am going to round this, and I'm going to just take 1, 2, 3, 4. Come on, work with me here. 1, 2, 3, 4 values. This 7 right here is going to tell us to round up. So we're going to have x is approximately, we can say equal for what we're doing, 1.2505. Okay? Now, in previous questions, it was really important that we acknowledged what quadrant this was in, or we're kind of unofficially acknowledging a quadrant, right? If you remember with tangent inverse, I'm not going to bring up a whole unit circle. We're going to pretend I drew a straight line just now. Remember, tangent inverse only lives in quadrant 1 and in quadrant 4, right? The other thing I want to point out is that tangent's period is pi. So this right here is going to require plus pi n for some n that's an integer. And this over here is going to tell us that there could be more answers, right? Because tangent inverse only fell in one of 2 quadrants. So how do we find values in those other quadrants or other potential values? Well, again, because tangent's period is only pi, I don't need to search for other values with reference angles. I can actually just use our other strategy where we look at solutions on our particular interval inequality. I can write it as the inequality here, right? So remember what we did in the past, n is equal to 0. So we're looking at x is 1.2505 plus pi times 0, right, which is clearly 1.2505. Now, it might be useful to us to acknowledge, I guess we could have done this sooner, but to acknowledge what quadrant this belongs to. So if we were to do some calculations really fast, it's definitely bigger than 0, right? Let's see if it's bigger than pi over 2. So I'm going to break out my calculator again, and I'm just going to find pi divided by 2. 1.57, right? So this definitely is between 0, 1.2505, and 1.57, which puts this in quadrant 1. Okay, so that was a value that lives somewhere over here, maybe a little higher up here, right? It's a little closer to that 1.57 than it is to 0, okay? So this would be that first angle that we're looking at. We can call it x. But there could be more values, right? Again, we're thinking here in terms of all one full rotation, right? And this has only taken us to the first quadrant so far. So what else is there? And again, the way to get to those other values is by just applying new values for n. we'll see a similar question when we get to the next example where we're looking at sine. And because sine's period is the full revolution, we'll have two options up here as opposed to just one. So again, this is happening because of tangent's period, right? And then this is helping us get all values on this interval inequality, okay? So if n is equal to 1, we get 1.2505 plus pi times 1, or x equals 1.2505 plus pi. And again, you probably know this after having used my math lab for most of this semester. Accuracy is important. So I'm going to go back to my calculator and I'm going to go back to the last couple examples. So here was our tangent value that we found, right? Okay, let's copy this. Copy. Okay, and we're going to use this value. Paste. Okay, and we're going to say this was our answer from the very first one, just the 1.2505, this up here that we rounded. It's the unrounded version. And we're going to say plus pi. Now, it may not seem like that's going to make a huge difference, but it could make a minor difference when it comes to these last couple of decimal placements. And again, the more accurate you can be, the better. That's why I went back to the original form, not just the rounded one. Do that whenever you can. So that sum, copy, that sum that we get, scroll up. So we're going to move this down here, and we get x is equal to, we get x is equal to all of this, and I'm just going to match the rounding I did before. So 1, 2, 3, 4 decimal places, and that 7 again is going to let us know what we have. So this gives us x is 4.3921. So that's a second answer or a second value, right? We had one right here. I guess we don't need the quadrant, but we had one right here, and we'll have a second one right here, and it is worth finding out, well, what quadrant does that live in? So I'm going to do the same thing as last time. I just want some decimal approximations, right? Last time we looked at 0, and this was equal to pi over 2, and I just want to figure out, okay, so this is definitely bigger than pi, right? Pi approximates to 3.14, so maybe it sits between pi and 3 pi over 2, right? Which would put it in quadrant 3. Let's find out. So 3 pi divided by, oh, it didn't read me right. So 3 times pi equals divided by 2. Well, 3 pi over 2, it's only slightly larger, but it is in fact larger, right? Gives us, let me write, 4.71. Right? So our particular value that we found, 4.3921, lives between pi, 3.14 approximately, right, and 4.71 approximately, which puts this in quadrant 3. So between pi, let me write 4.71 down here. And let me write 3 pi over 2, just so we're lining up what we got. Okay, so we've got these two answers. Now, we can go further, or we can check if we can go further. 1.2505 plus pi times 2, which is 1.2505 plus 2 pi. But remember, we're only between 0 and 2 pi, right? That's our maximum value all the way down here. So this already is too big. This on its own, and then we're adding to it already. So we're bigger than 2 pi, which is not an answer. Okay, so the only two answers we've got, let me write them out here, are solutions on 0 to 2 pi are x is equal to 1.2505 and 4.3921. And again, I did round those, so make sure you follow directions on what rounding is supposed to look like for whatever question you're working on, okay? The only other thing I want to mention, because I've talked about this in other questions as well, is remember we've talked about those general solutions, right? The ones that are kind of representing any potential answer, not just one specific one. Well, that would take us back to our original solution, all the way at the top. 1.2505 plus pi n for n belonging to the set of integers. So your general, really just solution, not even plural, is x is 1.2505, again rounded, so adjust accordingly if needed, where n is an integer. So this is not necessarily an answer that was requested here. Again, it's just so you can adapt depending on the question type. This represents any potential answer that's out there. This represents two specific answers that live on this particular interval. All right, that's all for this one.